started. Now I guess we are live. Hello guys, welcome to Let's Talk Signum number 3. I will start by sharing my screen. I'm not sure we are live or not. I hope we are live. So I will start by showing the first NFT at our network with unlockable content. Last stream we showed it with a new future, and Nivok rated use it first. You can read more about this at our Medium. With this Signum network, you can go here, and we have good article about this new feature. Now, this is Keep Talking collection created by Nivok. All this NFT is unlockable content hidden underneath. I mean, you need to collect all 15 to get a treasure. I don't know how you collect, but I will be giving away this. I think half this NFTs I will give away now. So to get one of these NFT, you need to go to Medium article about Signum unlockable content. All links are under this stream's description, so you can find this link. And person who writes comment will get the first NFT. So let's go. I made some promotion tweets about this stream, and will be giving away one of these NFTs. So we had 8 tweets. With this tweets, it's Nivok Twitter. Let's look who won. And it is Signum Billboard. This guy is created billboard. I will show. I now not prepared it, but I will show next stream. It is cool. It is cool billboard related to Signum. Next, I will give shout outs for Nivok. Nivok is a music creator. You can follow him at this Nivox.com. I left link under video. Next lucky tweet was from Signum official. We have 15 retweets. Let's look who won. And the winner is Holger Pedersen. Again, last stream he won one NFT, and now again. Next lucky tweet was Deletariums. He made it only 1 hour before the stream, so only 3 retweets. You can see one is mine, one is Paul Poker, other is Investor Boy. So I will do it live. Paul Poker and Investor Boy. It's 50-50. And one Investor Boy. Congratulations. Next Sunday we will have our stream with Alista. We will show some his community related to Signum he created. Okay, now I will give my word to Deletarium. He will represent his creation, his compiler. Okay.
Yeah, talk a little about me also.
Okay. About you?
Yes, yes. But
Delitarium is
yes,
our
yes.
main developer of a Signum network. He
Oh
created
no, this
compiler. Okay.
this nickname I had is from many years
Okay.
ago. This is not only for the Signum. This is like 10 or more years. I have this nickname, and I would like to share my screen here, and you must allow me to do this, Chefas.
You cannot do it. Okay.
Yes.
Sorry for problems. I need to make you co-host. Please try now. I just checked we are live. All people who want can ask questions. Yes, I see.
Okay. I think you can see my screen, right?
Yes, we can.
Okay. I prepared one presentation a little about me and about Smart C, and some also about programming on blockchain. I will start with Smart C history. That it started in I think March 2021. This was my first program, for a compiler. It was a simple assembly processor, and this was the prototype of Smart C. It's just a very simple program. This is a front end to help to code in assembly. You can just check it was this way, and process code just to be simple to make these loops in assembly. And then I thought, why not C? It's so simple. And then I started to program the Smart C in C language, and this was very hard and very difficult because it's not like assembly. The high level language have this abstract syntax tree, and this is recursive to code the nodes. You have to enter, and again, because for simple recursive functions, you can see everything in just a little function. But when you have a compiler or for a language like C, the recursivity is huge, you and very hard to think about it. I almost gave up this time, but then I could do this. And the first release of Smart C was released in July 2021.
Sorry, Delitarium. Can you explain what is this function? I don't know how to pronounce it.
Recursive functions.
Recursive. It is
Yes, when you
recursive, like recursive, but not recursive.
yes, it is recursive, but it's not a simple
Okay.
function that you have like in the examples, like Fibonacci. People the traditional example for recursivity, but for the language, the processing nodes are huge. You have 10, 20 types of nodes. You have to go recursive every in each one.
Okay.
Check there. It's crazy. It's crazy. It's crazy. Yes, and then the first release of Smart C it was this one, the page. So some friend helped me with the front end, the colors, and it was working for the C coding. For This previous version, you have always to set the Pragma version. And you can see that it was compiling in, I did some good programs with this version, the first version. But this code was messy. It was in JavaScript, and I found some bugs, and it was way difficult to spot the bugs inside the code because the functions were huge. And I'm not a programmer. I'm a mechanical engineer, and this was a project for the spare time. But it became to be so great that I think now I'm programmer. And then for this version 0.2 and 0.3 for Smart C, I was just fixing the code and trying to make it better. So I decided to refactor and to code in TypeScript. And at this time, O'Hagar have helped me a lot. I was messaging him every day with some messages how to do this, how to do that, and O'Hagar helped a lot. And he told me to use Sonar Cloud. That is it's a page that will check your code to say that it's good or not good, or where you can make it better. Yes, and and this one was the most difficult part of the refactoring, because I had this code generator function, and Sonar Cloud told me that the cognitive complexity was 1,600. I needed to decrease it to 15.
So he noticed that other people's not understand this function.
Yes, yes, most probably. I was just thinking if it was just me, that I'm so smart that my program is so good, or maybe I'm just a bad programmer. And I think it was the second option. Yes, then in January 2022, the Smart C version 1.0 was approved by Sonar Cloud. And I will open the page for Sonar Cloud here. You can check it. Smart C is now all green. This is a very difficult to get this everything here in green.
So you learned to code by coding.
Yes.
I mean,
yes.
JavaScript, TypeScript.
Yes. Sonar Cloud helped me, and also O'Hagar. And O'Hagar has a project that is a Signum JS. The Signum JS was my oracle. When I would like to know how to do something, I just go there and check how O'Hagar did in Signum JS, and I just would do the same in my program.
Nice.
Yes, and then we had some new features to add in Smart C. And for this last 2 months or so, more or less, I was working on creating a NPM package. So now we can add Smart C, both front end or back end with running Node, and everyone can just add npm install Smart C and can compile the Smart C programs inside another project. And we have here many versions for the Smart C. The latest one is 2.01.
No, it is a very modern approach.
Yes, I was having a problem because I was trying to update the SC simulator, and I was trying to do something there, and I would like the assembly highlight library, and it was inside Smart C. And I changed it in Smart C, and I would like to change also in SC Simulator. And I just need to get the code, copy and paste in another project. So it's much better just to have a library for the highlight, and I just add the same library in both projects. So when I update the library, both projects are updated.
Great.
Yes, and then during this during the last months also we had the Signum node for the Rainbow hard fork, and I worked a lot also with Jaws to test the Signum node and try to break it, to test everything there to for I mean in the smart contracts. For this Rainbow hard fork to update the Smart C was very simple because just I need just to add the new API functions, and this was very easy, no big deal. It's like 1 week and it was done. But
Like
in
said, 1 week, this is not so simple.
yeah, but it's feasible. It's feasible, and I'm not working all the time in this project. Okay, I do a lot of other things, like and, the homework also.
Okay.
And in the last minute, when was like 1 or 2 weeks before the hard fork go live, I saw that coding in Smart C was very difficult because some of these new API functions are different. I mean, the same API function can do two things. They can like send a Signa or can send tokens. So depending on how you use it. So it was becoming to be difficult to code in Smart C. And I decided to add the built-in functions based on Smart J. That this was much more difficult to do this. It was like 2 or 3 weeks working, and this time working hard. It's not like the first one, 1 week just easy, you know. This was 2 or 3 weeks working hard. But I could do this, and Smart C was released starting this this month, and the code is very good. We have the API functions, so we don't need to check anymore the A and B function, A and B registers that are linked to assembly code. So no need to assembly. Okay, no need.
So you created bigger abstraction. I mean, no need to know
Yes.
so low level stuff.
Yes, yes. Just before in Smart C, we need to use the same API functions that we use in assembly. But now, no, now you just use the function send message, and the compiler do all the steps
All
that
the
you
stuff.
need to do for this message to be sent. Okay, I will talk about also about how to program on Signum blockchain. We have some no very much a lot of limitations when we want to make a program for
I think in general, smart contracts must be small. They do
yeah,
not need to be big.
In Signum now, we have a 40 code pages. This is like 10 kilobytes. Can you imagine this? This is like to be again in the stone age of the computer. We have a fees for every instruction. So every single anything that your contract do, you are charged for a small fee. So if you just do a very big loop, you can easily spend all the balance that are in your smart contract with the fees. So the program must be very, very concise, very small. We have the block time in Signum. This every 4 minutes we have a new block, and there is no way to just make a contract that is online all the time. I mean, coding something. We must be with this in mind. The program must stop and it will be activated again only in 4 minutes. When we are coding in the regular programs in computer, the computer is always available. You just tell the computer to do something and the computer just calculates, and most of the time you have a spare processor for do what thing you want to add in your program. And we have the delay for processing. The transactions are not processed as soon as they enter the blockchain. Smart contracts will process only in the next block. So when I want to do something in a smart contract, I need to send a message. The message can take up to 4 minutes to be processed in the blockchain, and then more 4 minutes for the smart contract to process this message. So it can take you between 4 and 8 minutes to process one message. And this is a big limitation most for games, because people want to play and do not want to wait 8 minutes to the result. They just want to click and ready. We have no hidden memory, so there is no way to get some variable, some secret inside the smart contract. All the memory is available. Anyone can inspect the memory for the contract. This also it's also not possible to do some cryptography with the smart contracts, because you cannot keep the secret. And it's impossible or very difficult to upgrade, because once you deploy the contract, you cannot edit the contract. The contract is there. If you want to upgrade the contract, you must think before deploy the contract, or how you will update the program on the fly. How can you change the memory from the contract? And this is very, very difficult.
Can we talk a little bit about these limitations? I have some question. Can you go once one? Yes. So can you explain why we have these limitations? I want you, but you explain for people that these smart contracts all computed by all nodes, and why we have these limitations.
Yes, this is the blockchain characteristics, or the feature of blockchain. All the nodes must compute the same thing at the same time, and must agree in the outcome of some contracts. Then every block, all nodes calculate the smart contract, and the result is stored in blockchain also. This is the same good things that we have in blockchain, that we can check the traceability of transactions. We can also inspect the program's memories from some height in the past. We can just check what happened in sequence, and the result must be the same.
Yes, and it is related to the node requirements. I mean, we try to make our blockchain that every person can run the node in simple computer on very, and it took not much resources.
Yes, this is the way the smart contract was developed in Signum. This Signum, why I think it was the first blockchain to have this smart contract. It was very.
I can explain. Siam, it's I don't forgot his name. I I don't know now. Don't remember. He created for this all this stuff for Bitcoin, and he hoped that Bitcoin hard forked and accepted these instructions, and other blockchains accepted these instructions, so they all can communicate and so on. But of course, Bitcoin do not date it, and NXT took these instructions when Burst developer took forked NXT, and we are now Signum. So this history.
Yes, this was 2014, I think.
14. Yeah, we are first public blockchain, public, not private, public blockchain with smart contracts. It's few months before Ethereum.
I my history in Signum started in 2017 when I bought my first AGD for mining. So at this time, I was just know that Signum was a good blockchain because it was green, and now I was linked to this this blockchain since then because I believe in the green things.
Yes, I think we all started by mining.
Okay.
Let's move.
We have also the strong points that for this program in blockchain. They are 24-hour running. There is no downtime. It does not depend on only one server. You can just code your program, and all the nodes will do the calculations for you. And this is a good point. And also they are unstoppable. You cannot just shut down one smart contract, or you need to shut down the entire blockchain for this to happen. The code can be inspected by developers. I know that it's not so easy to inspect one deployed contract because it is deployed in machine code, but it is possible. It's possible to reverse engineering the code and to check and inspect all the memories, the values in the memory. So it's very difficult to hide something inside a smart contract. The smart contracts are upgrading the Signum every day. So we have one new idea, and we just develop one smart contract, and now Signum has another feature. I think it's very, very crazy.
Yes, I can give some inputs here. Because we are small, we can do hard forks, I don't know, every month, or I don't know, we have small community, so there are no big problems like in other chains, which have, I don't know, many other problems when you have very big market cap, and etc. We can upgrade and we will upgrade.
Yeah, and also the smart contract. You have the blockchain, and you have a new idea. Like, let's do one token that we can mine with my smart contract, and bam, you have a token that you can mine with smart contract. You didn't need to change anything in your in your Signum node. You just code a new smart
After your
contract.
presentation, I will show your game. We have some guy which who released token, not token, NFTs, and he sells these NFTs and gives this mining games tokens.
Yeah,
We will see.
yeah.
I will show.
This is not my game. I just programmed the game, but now bigger. I don't have any control at this anymore. This
Yes.
is
You
now
have
hard.
no pre-mine, no ICO, nothing. You
Yeah.
just release it.
Another good point is that Signum bytecode is simple and very good against bugs and attacks. Yeah, we have some news about hacker attacking other blockchains like Solana and other, because the smart contracts there are very powerful and a lot of things to make them power, but this also brings a lot of vulnerabilities to them. The Signum bytecode is from 2014, and this is simple code. You cannot execute something that a user send to the smart contract. It's very hard to hack one contract in Signum. Yes, and for the smart contracts, we have the all the features that we have in blockchain, that we can inspect the memory from the past. We can trace all the transactions that were done to the smart contracts. This is all included with the blockchain. And we have here also people that have new ideas to make some new programs, new smart contracts. And it's very good to take some time to evaluate these ideas. In Signum, before the hard fork, we had just the simple lottery games that was simple to code. And we had the hard to implement projects that were difficult to code and very big. I just bring here the Stellar Duo and Signum Art NFT that are very big programs if you check the source code. Now with the hard fork, we have tokenization, bringing us a new possibilities for the contracts. You can just do like an token exchanging with smart contracts also. And I think the most important thing is discuss with experienced people, because most of new ideas were already proposed some time ago, and it's very easy to think that you have a new idea, and this idea is not new. A lot of people just have the same idea in the past, but they just think about it, and there is some problems. Uh, Most of them, I think it's related to the blockchain time that take 8 minutes to code your program. Like, I want to make a casino, and then you can just well, how you do a casino where your player will play a game and the result will happen only 8 minutes. After 8 minutes is nobody will play it in this time.
I will interrupt. So it's why I think main developers Ohaga and Joss are preparing this multiverse where you can easily create your blockchains with your parameters. I mean, fork your Signum node and create your coin with, I don't know, what you need for your game. And we will have link with Signum blockchain, with BTDEX. And I'm not sure about all this stuff. I'm not developing this, but how I understand what the strategy for our platform is.
Yeah, this would be great because we have now some blockchains that are fast. Some others are more, they take more time to process one block. And most of the times when people want to make something fast, they will choose one crypto. But if we can do this in Signum, so with the same blockchain, we can have the classic processing, and we can have also the fast, like the fast track. It would be great. Okay, I have here prepared also to code a smart, a simple program.
So maybe let's give away some more stuff. I see we have 10 viewers. I will share my screen. Yeah, I said this that we will have next Sunday our stream. I have some promotion for Roman. He gave it away this collection, and he created a few videos. You can find links in description how he painted them, created, and this is a live video how he created all this stuff. It's painting videos. Next project is related to Deletarium, the mining game.
Not mine.
Maybe sorry again. Maybe you can explain what this game, how it's doing, how it's working.
Yeah, this program is just an idea that maybe we can make a token that are not created by a user that just create 1 billion of the tokens and do something. We can code a token that a smart contract just check the meaning from the other people and give this token to the better one. So this was the base idea, and then I had this idea to make the donation idea. You just donate some Signa to the contract, and then you can win or not a token. And every day, if there's some amount of Signa inside the main contract, it will be distributed among the token holders. This is the base idea.
Okay, thank you. So one of miners VCX created these NFTs. So you can watch more about them in this video. In description, you can find this link. I'm not sure how he's given, but all these NFTs related to a token which you can mine in this game. And token pays dividends from how is Deletarium it is working. Miners mines by sending Signum to this smart contract, and it mines tokens, and this token, and for these I don't know how to explain it.
Okay, I can explain. Okay, you deploy a contract. This is the miner contract, and then you choose a intensity to mine it, and well, this intensity is the amount that your contract will send every hour to the main contract. I tell the main contract the picker contract, and this one that the players deploy are the miner contract. And then picker contract every hour picks the best deadline that was sent. And the deadline is the transaction ID from this contract to contract transaction. And depending on the amount that it is configured, this deadline is divided by a number. So more the people send the signal, so the best the deadline they will have. And this will be random because maybe people with mining intensity that is low can get one token, but it's an average. So most of times the people, the user that plays with the biggest mining intensity will get a token.
Okay.
Yes, and every hour the picker contract gets all the balance that was sent in the last 24 hours and send to the holders of the token, the TMG token. So while there are people mining the token, there will be distribution. If today nobody's more wants to mine, so no more distribution. This is very simple.
Sounds not so simple. So this guy created these NFTs, and we will give away this free. So to get them, we have now 10 viewers. You need like previous time like it. You can see there is no likes on this. I can push yes like NFT, and I will check in the blockchain the secret password. Let's see. I will check in the blockchain who like it, and I will send these NFTs. I will send not for one. I mean, if one person likes all three, I just send one. So you can. So it will be three unique viewers. Okay. So I think we can start programming. Okay, I'll stop share. Stop my screen. So what we will program?
Yes, for this for this presentation, we just do a classic hello world program. We use the Smart C web UI, the user interface. This is the default user interface. I have spent some days programming Smart C Retro UI that is based on Stellar Duo game, and it's the one that I use most of the time, but it's not ready yet. And if we had time, we will use the SC simulator to test the smart contract. Oops. Sorry. So this is the web page. Always when I want to start a new program, I come to the help, where we have a lot of information about Smart C. This is the help is very big, and I think all the needs that you need to know are here. We have the examples, and from the most simple example here to the most difficult to do, but all these are the simple ones. This is not so difficult. We have the echo message. It's a program that the first message that is sent to this contract and sends back to the sender. I will just copy this program here to use as base for our coding. we can use here the web user interface, but I want to show also the retro user interface. So come back here. Yes, this is like the
Yes. Yes.
but this with this here we have the code mirror library to write the programs. So it's the same library that you used in GitHub. So it's much better to program here, to code here than in the regular user interface. So let's go. When I start code, I have these parts here that I do. First, we have the program and pragma. These are the program name, the compiler directives that I do. Then we have here the global variables that I use in the entire program. In some programs we have here some startup code, because when we have the main function on Smart C, after the first message, all the messages will be processed inside the main function. So the code that is just above the main function will be executed only once, only the first time you send money to the contract. We have then the main contract here. That is the main loop. I like to keep the main loop simple and do the things inside the functions. And the last one, we have the functions. In the functions, we do what are the things that we want. For this case, we want to show you the hello world. So in the main function, we have the main loop that will loop through all the incoming messages for every block. And once the block is done, we have no message to be processed in that block. We have here a cleanup routine that we can do. But for this one, we will just reply to sender a hello world message. So in the main function, we will use here the get details function to get the sender with the built-in function get sender and the amount that this sender has sent to the contract with the get amount fx. The fx is because this variable is fixed. It's not a long type. And the read message. But for this, for the example that we want to show you, we don't need the read message. We just need to know who are the sender. And after that, we will just process this transaction that was received. In this transaction, we will just reply the hello world. So we will use the built-in function send message. Send message. We can inspect all the built-in functions inside the help. We have here the built-in functions. It is a huge page. This page is very, very, very big. For the first part here, we have just the prototypes for all the functions that we have. I divided them in the types. So how to handle the loop, how to receive transactions, how to send transactions, how to get blockchain details, how to get contract details. So you got the idea. For the send message, we have here send amount, send amount, so get it bigger here, and send message. Send message, we need to send it a buffer with message and the recipient. So let's code this. For send message, we need to send a message that will be, I will call the hello message and the sender. So we need to define here a variable hello message. And we need to set the message. In the first time that we run the program, we will set the hello message. Hello world. So the hello message will be always the same. We don't need to change. So we just set one time and we are good. And for the transaction, we just send the hello message to the transaction, the current TX sender. Okay, let's compile. Let's see if it's compiled, F4.
Successful.
Okay, good. This contract seems to be good. And we can we can test and debug in Netc Simulator if we think that it's okay. Okay, do you want to test the code?
Me?
Yeah, we had do we have time? Like 10 minutes?
I'm not sure. I will have many questions, maybe.
So you can ask the questions. I will stop here.
So you, I need to that you show it code. I see you set for that you say this hello world variable array for. What is this? Is for? It's 4 bytes, but not bytes. Hello world cannot.
This is because the message in the Signum blockchain, they are always sent in pages. One page is 32 bytes, and these 32 bytes are 4 longs because each long is 8 bytes. So when you want to send a message, you have to have this packet with 32 bytes.
So this number represents pages.
It is one page. One page is 4 longs. So that's why we need a buffer that is 4 longs.
It's 4 longs.
Yes.
And how you know that hello world takes 4 longs, not 5 longs?
Because 4 longs is 32 bytes. The 32 bytes is 32 characters.
How much you 1 byte, so 1 character?
Hello world it's much less than 32 bytes.
So it is using UTC characters, I think, or what we have universal, and we have older stuff with, I don't know how.
Yeah, we have the ASCII code and we have the UTF-8. Yes,
and I think for you to say you need for regular letters 2 bytes, no?
One.
And
yeah, for regular one is just
letter
one.
not regular, then it's 2 and 3 if it is regular.
Maybe 2, maybe 3, maybe 4. But I think Chinese characters are 4, but
But
this,
all the regular English letters is 1 byte.
yes,
Yes, I don't remember. So you write 4 longs. It's 1 long is 8 bytes, so 8 characters. So you think that so it can be in 3 longs. Hello world. Why you write 4,
I,
not 3?
because if I put there 3, the send message function will send 4 the 4 memory locations. If you define your buffer with 3, the size is 3, so there will be buffer overflow when the program reads your
So messages always use 4 longs.
for this send message. Yes,
So it's 4, not more, not less. So
correct.
so it's 4.
Yes, and of course you can have a buffer like 100 longs, but the first 4 characters for the first 4 longs will be sent. If you want to send the next one, you need to advance your pointer and send to the send message the pointer to the location that you want to start the message to send. But this is this is C code and pointers. It's not so easy
Yeah,
for.
I remember with stars, and for me it was not easy.
Yeah, because the hello world most of the time it's the easier program, but for the C and Signum blockchain it's not the easy one.
Easy.
Yeah.
Okay, maybe I will show some community stuff. I want to say that technology is very important, but all technology is for people, and people are important. At first, it's people who use technology, and technology is to help people to communicate, to cooperate. So people first. So I want to give some shout out for Discord. So Discord is our main place where we connect, discuss. Here is a main Discord signal. You can see Talk General, its main channel. And here, first person who enters his account ID, or also known as wallet address, will get one of where was link, one of Keep Talking NFTs. I will give shout out for Delitarium's Discord. Here you can see other games different from mining game. I think we will show other games in other streams. There is other Discord channels, but I think I will limit today on this. So next communities are in Telegram. Here you can see main Telegram English speaking Signum network with 2,000 members. Here you can see, and we have other big communities, Russian speaking, 1,000 members, and Roman is Russian speaking, and other members. So we can say that our community are international. Delitarium is Brazil, Oliver is Brazil, and I'm Europe, others Russian. So here I will say several sentences in Russian for Russian community. Привет, ребята, которые слушают теперь этот стрим. Напишите свой адрес на Signum Russia Telegram channel. I am starting to speak half Russian, half English. когда человек, который напишет свой адрес, получит один из токенов. Okay. And same goes to English Telegram. One person who writes his address will get one of these Let's Talk tokens NFT. It must be a different person, so not only one person takes all. Okay. Next community I will show is Reddit. We have it is more for United States. I don't know where Reddit popular, but it's not in Europe. Here we have 811 members. Here you can see an announcements for these streams. So who wants to get one of Let's Talk NFTs? You need to go to this thread and just paste your address. So I don't know, I lost count, but I think I just give away free. Yes, I give away free on Twitter, free now. So we give 6, and next Sunday I will give other 6 away. And all this collection will be given away, and you will need to communicate each other to take secrets. I tried to say it before, but I will repeat. So every token has unlockable content, and owner of this token can find what is unlockable. And you will need 12 parts to collect to one place, and you will get a treasure box. So it's, I don't know how you will cooperate, but I hope you will cooperate. Okay, I don't know where we are 1 hour. Maybe we can have some discussion, or I don't know, I will see, I will look to questions. In the hello message example, why did you need to define a variable for this instead of just inserting the message directly into the function? Why just set the message as variable, not directly? I think it's just programming.
Yes, but this is because in the regular programs, when you just insert a constant like a string, it will be addressed to this constant in somewhere in the code. But in Signum blockchain, we cannot send an address an address pointer that inside the code. You just need to send to use the variables that are in memory. So you must bring this message, this constant that you write there, that will be wrote in the code, to a memory location, and then you send the memory location to the send message function that will get the memory location and send it to the recipient.
So we cannot directly write.
No, we need to get the code, go to the memory, and from the memory send them to somewhere. And of course, I could do this in Smart C. I can like get one argument function that is text, and I could get this to work. But when you have this program, this problem, that you have to have 32 bytes in one page. If someone writes the hello world, I try to read that, I will send some trash that are in the memory, because this string will be lower than the 32 bytes. That's why we need to reserve this message, this memory location with 4 longs for the message.
So this architecture protects from memory leaks and other bad things which can happen.
Yes, and this is the security reason in Signum. We cannot execute something that is in the code. We need to bring it to the memory, and we cannot tell the program to run some code that is in the memory. We have also this limitation. We must we must run the code that are in the code, and you use the memory, the values that are in the memory. We cannot just send the code to be executed something that is in the memory.
We have a question from same person. Is this just for messages or for all functions?
This depends on the function. We can get the help, and in the help we will explain all these things. Of course, in the send message help that I told that I in the help page of Smart C, if we go there for the send message, I wrote there that the buffer must be for longs and all the things that can happen. Also, if there are some functions that if you send 0, something happens, and if you send like the other value, something different can happen, and this is in the help.
We have another question, but for example, in your dropper contract example, it is necessary to define recipient and there is address signal. For example, in your dropper contract example, it is necessary to define recipient. I don't know how you can remember what you program in a dropper contract.
I can get there in the Smart C page. I'm opening there.
Okay.
In the samples, the dropper. Yes. Okay, so
is it
the question
necessary to define recipient?
Yes, of course, because the dropper will send some amount of signal to a defined account. So if you do not define the account, the memory will start with 0. All the memory will start with 0. So
sorry, can you show this contract for viewers? So
yeah, okay.
So about what we are talking. Well, I see it's in 12, line 12.
Yes, just to here. When we start the program in the Signum blockchain, all the memory will be 0. So if we do not define the recipient here, we must first thing that we will have is a error in compiling because we don't have the recipient defined. But if you define a variable to be the recipient and do not store any value there, you will just send to the address 0. So you send it to the burn account.
Okay. So it is related with how memory works at smart contracts.
Yes, this is the main reason. Another option would be just to use the get creator built-in function. So this dropper will always send the message to the creator of the contract. So if anyone sends some balance to this contract, it will send it to the creator. This is another idea.
I don't know, he is writing that I'm asking because defining so many variables will make the code longer. But I think it is cool when you can define at start.
Yeah. When you have the defined the variable here defined, you write this in the code. So yeah, the option when you need to set the memory from the beginning of program. So let's say you have 10 pages of memory to be filled, you must fill during the deployment, and then you can use the const uh, keyword, and this will be set during deployment. You will not make the code, we will not need to write this variable into the code section. You just you just write it to the memory when you deploy the contract.
And I think it is good practice to define your variables, use it at the start of your code. It's
Yeah,
all
again, it depends, because if you want your program that to be to send always the amount for some account, it's good to write in the code, because if you make a green copy of the contract, this address will be in the code. But if you want a user to choose the address, and so better you write this in the machine data, use as const variable.
Can you speak more about green contracts or show example or something? Because I think it is very cool future and it's very genius stuff to think.
Yeah, this right now I don't have this prepared for Smart C, but I had one video where I show how to deploy this contract. Like this
Can you
here.
promote your YouTube channel so people can watch?
Yes, it's Deleterium. This my channel. Let's open here. I think I'm logged here.
It is Portuguese language.
Yes, because I'm from Brazil.
Or Brazilians understand Portugalians, or it is very different.
Yes. Most of time it's yes, but
Most of time.
yeah, but people must speak slow, not like
Not fast.
when they are screaming with each other, so it's very difficult to understand. So I have here this video where
Okay.
I show how to deploy the green contracts. At the time, I was telling them as carbon copy, but now we are on the same page to call them green contracts. But for this to happen, we needed to deploy a first time contract and get the full hash of that transaction. So the next time you want to deploy a contract and you have this full hash, you can use it to save some space, some bytes in the blockchain, and also the deployment fee of your contract will be lower. In the Smart C contract, I have here the referenced the transaction full hash. So if I have this echo message and I know that this full hash is something, I don't know what it is, but I can come here, write down the full hash. I just delete the bytecode because it will not be written on the blockchain. And then I submit this to deploy the green copy.
And it will, what advantages give?
Yeah, for the users, the deployment fee. So if you have a very big program, like 10 pages of the code, and you need just one page of memory and stuff that, If you want to deploy the first time, it will cost you 1.1 Signa. But if you are just doing the green copy of this contract, you need to pay for the memory only. So you deploy using 0.1 Signa.
So it's 10 times?
Yeah, it depends on the program. You don't need to pay for the code of the program, just for the memory.
Great. Okay, do we have questions? We have some, but I don't know how to explain it. Okay, I don't know. Maybe I will promote next stream. Next Sunday we will have some not so technical. We will have Alistair. He is from South Africa, and you. I think he was in our streams maybe a few years ago, maybe 2 or 3. He will show about his community. I'm not sure what it will be, but it will be not so technical and more entertainment. Okay, Deltarium, thank
Good.
you. Okay, just don't finish the stream. I just will